So good morning. This is your good friend Dan here, and my friend and business partner Justin is running the camera. It's February 24th, 2022, and I'm going to talk to you a little bit about the software side of our project. This application you're looking at right here is called JS8 Call. It's based upon a piece of software built, I believe, at Princeton University called WSJTX. WSJTX worked with a kind of mode, a communications mode, or rather encoding called FT8. And FT8, and I know this is a lot of confusing verbiage, and we're going to talk about that in a second. FT8 allowed people who used WJSTX with their amateur radios to send digital messages back and forth. And again, the radio technology that we're working with right now, CB radios, because people have them, are they're very narrow bandwidth compared to the internet. You can't really push that much data digitally across CB radio, but you can push a little. This application called JS8 is based upon WSJTX. This little text box here is where you would type a message, and then as quickly as JS8 can encode the message, it would broadcast the message, and you would actually see it showing up on a waterfall down here. We're not connected right now, and again, this is not our application. This is an application developed by somebody else. This application has an API, not really well documented. We'll talk about that in a second. The API allows UDP and TCP/IP protocols to interact with the application like it's a server. So if you have JS8 Call running, you can think of it like a server application providing services to other programs. Our program is going to be a combination of some fairly straightforward technology. What you're looking at right now, if you go to planetarystatusreport.com and you click on the notes link, you'll go to this. And this is essentially a bulletin board. There's no login. We don't want your passwords. We don't want any of it. And even though there is encryption functionality, the encryption functionality happens completely in your browser. It is something that you control. It is something that, assuming, and again, a lot of what we have are assumptions. We assume our computers are safe on this side of the internet. And everything happening in the browser, in theory, is happening in a sandbox on your computer. So if you encrypt it here, it's not being encrypted on a web server someplace. It's being encrypted right on my laptop. And so you can take that text, post it into a message, post it into an email. You could post it into a text message on your phone, and you could use this tool. And I'm mentioning this because, like I said, the application itself is designed to be a bulletin board. What is a bulletin board? A bulletin board is a public space. It is a space available to everyone. Up here it says node UT124. And you don't need to think about that, but what that means is that there is an IP address associated to this household, not a specific location. Everybody who works with, everyone who is a customer of our current internet provider shows a geographical location of the golf course in Roosevelt. So if you're thinking, oh my God, he's tracking IPs, let's get that out of the way. The internet in part only works because IPs are relatively stable. That's number one. Number two, everybody uses IP addresses. What we've decided on the website is that that's all we're going to use. We're not going to collect your personal information. We're not going to, spy on you in any way whatsoever. This is Brave browser I'm running, okay? If you look up here, right up here in the corner of Brave browser, and you go to this page, you'll see 0 warnings and 0 issues. You go to any other website with Brave browser and you'll get nothing but alarms. That's an important distinction. You can go to this site, doesn't matter who you are, you click on note, you can type in a note like say, hey everyone, we are here on the World Wide Web. But in a few days, and again, it's a few days away, we're going to add something called a command tag. And a command tag opens with the greater than arrow, and then some command like send. And that command by itself when read by the software, will actually direct the message from this application running on your local computer, because we're going to basically use Apache Web Server as a kind of user interface provider, in essence. We're going to use it for our UI. So you'll run a little version of Apache on your machine, running LAMP architecture, Linux, maybe not Linux, maybe Windows, Apache, MySQL, and PHP. And when you push save here, it won't work here, but when you push save, the program that monitors the queue will pick up that message, send it to JS8 call using the API. There's a command that actually will send a message right into this text box, and it will push the message through. We are going to make this as invisible as possible. We're going to abstract this out. Now let's talk about this. In the last 20 years, user interface design for software applications has gone through a lot of development towards what I would call rational simplicity, which means that things that can be reduced to a script or a wizard are. It means that you're not as cluttered with information in most modern applications. You look at this thing, all you have are question marks. You have lots and lots of buttons, lots of menu options. If you say to yourself, I just want to send a digital message over the CB radio, there's a lot you have to do here in order to make that happen. And I would argue that a lot of it could be automated. And then there's the question mark, why wasn't it? Why wasn't this simplified down? I mean, right now, frankly speaking, I think this is too complicated of a user interface for most people. What we're proposing is going to be really simple. You're going to have power tags like the tag, I showed you, the send. You'll have a power tag for send. You'll have a power tag for email. In fact, I'm going to pull these out and make it bigger so we can just make it easier on everybody involved this morning. Hold on a second. And I don't know how we're doing on time, but you tell me.
We're looking good, Dan.
Okay. So the power tag, like I said, is going to have this greater than symbol, I guess, and some command. And these commands are going to be simple. And they're going to be designed to be compact because these commands will actually direct something to happen, on another computer, someplace else in some cases.
Wait, so you're saying when you use the command email, it will send an email?
It will send an email. We'll have a command for SMS, and again, after the colon will be some number, and the message, these will be included in the message notes. So when the computer reads the notes in the queue, it has the message and it has the command and it knows what to do. If you want to, in computer science terms, understand this, we're building a very simple declarative language. Very simple because we're dealing with narrow bandwidth. And declarative in the sense that you're not going to be writing a lot of procedures with our language. You're going to be telling the computer to do something and it's going to go do it. You might build simple linear scripts in the future. Maybe it gets a little more complicated, but we don't want to go there. Another thing that we're going to be working on related to this, and I'm going to switch back to the website here. Another thing we're going to work on related to this is the ability to do remote procedure calls using our architecture between one computer with a CB radio node set up and another computer with a CB radio node set up. And what do I mean by remote procedure call? I mean literally sending a list of arguments to some function on another computer that's connected to a CB and having it do some activity. And again, do this with security, do this with whitelisting, do this with things like voice recognition. I'm not a big fan of voice recognition in terms of the way the deep state has used it. But if you wanted to, for example, order a pizza using our application in a couple months, here's how it might work. You might have a form that Pizza Hut broadcasts on some frequency. Here's a simple form, some, field name colon, some field name colon. Here's a simple form, submit it. Here are your simple instructions. And one of the instructions is on a different frequency to actually repeat the phrase that is in the form. Like there'll be a form entry that says, here's your daily phrase. You go on the voice channel, you say, I confirm order, and here's the phrase. The voice recognition software at Pizza Hut takes your order, takes your voice, matches them, and now you're getting a pizza. And this could be done just with a CB radio. So when people say things like, okay, Dan, I mean, it's CB. Let me talk about that for a second. We are starting an engineering company, RAD Engineering, R to the E. I think that's pretty cool. And one of the quotes we were thinking about using is RAD Engineering : the frequency is the limit. Right now, we're working with CBs because people have CBs. But there is nothing about our strategy that restricts us to CB radio. There's a WinLink project that uses FM. And FM is a different way of using the same bandwidth to encode more information. So on an FM frequency, we'll be much faster. Now, you'll say, well, Dan, does that mean we should wait until you have the FM? No. We're not going to do what Microsoft does or Google does or Amazon does. We're not going to say, well, because everybody's using the Xbox 5000, all your old Xbox games will no longer work. No, we're going to support all the frequencies that people are on. People will be on CB radio, they'll be on FM transceivers, they'll be on UHF, VHF, and one day, microwave. And if RAD Engineering gets to do the stuff we want to do, one day we're going to build autonomous lighter than air drones, like basically suborbital satellites that will be at between 10 and 20 miles up. And these little drones will actually help relay radio traffic, increasing the bandwidth more. And all of this will be done in a distributed, truly decentralized way, not just in terms of technology ownership, but in terms of technology understanding. We want to educate people. Right now, this planet has a plague of learned helplessness. What we want instead is a kind of learned helpfulness, a learned capability, a competency. So we're not interested in making $1 trillion. We're not communists, but we're not interested in stealing people's money. What we are really interested in is building a kind of internet that they can't stop. The RAD terminal will have all the pieces with it that if you plugged it into a Wi-Fi router, you could make the notes application on that RAD terminal available, and other neighbors in your neighborhood during a blackout, during an emergency, could log into your network, post a message. You would still have control whether to execute, because again, unless it's coming from your IP, execution is paused. But that means your neighbors would have a chance to maybe let their parents know they're okay, let their family know they're okay. In a situation where some of the internet's up and some of it's down, this can be a way for that information to flow through to family members, like I said, during a disaster, for example. If you're out camping someplace, you'll be able to connect with friends and family using our software.
Maybe play a game of chess?
Maybe, absolutely. In fact, the chess game is going to be one of the first things we facilitate. We're thinking about a lot of what I would call low bandwidth text game type stuff. And since it's going to be an open architecture and a really simple architecture, I think a lot of people will start creating little text games again. And again, it'll be different, it'll be weird, and it will be fun. But are we stopping at CB radio? No. I mean, one day we want to be capable of producing not simply the best computers and radios around, but we want to produce a RAD terminal that would always give you the most optimal and fastest connection no matter where you are. We want to build a system where you can just go anywhere and you don't have to worry about the government, some corporation, some jackass in Hollywood. You don't have to worry about being canceled or removed. And listen, the bulletin board application, you need to think about this for a second. You go to a McDonald's today and you use this. You use their IP address. Well, guess what? That won't be connected to you. You use the encryption to post a message. This is a way for you to talk to somebody in the most anonymous and secure way possible. That is how I would explain the vision behind this. And this will be capable of taking CB radio messages that come from our system, our network, and posting them publicly. So if you're in the middle of nowhere and you've got a RAD terminal, you could post a help wanted, you could post a for sale ad. I mean, what did you say? This is like Craigslist plus Napster plus,
some Twitter bit to
Yeah,
it.
Twitter. This is basically a form of social media, but without the socialism and without all the crap. This is a social media that, guess what? Nobody's really going to know who you are unless you want them to know who you are. And if the power goes out for you, guess what? You'll flip from whatever node you're on today to a different node, because that IP address is the only thing we track. And I think that's pretty cool. Some people might say, well, what about my ego? Well, you know what? Maybe in a couple months, when we get enough money in, we'll actually add a pay for feature where you can feed your ego and people can know who you are and you can have a stable presence. If what you really want is your identity to be fused into a database someplace, we'll sell it to you. But actually, I think it would be better just to be anonymous and just talk to people, like this English 11 guy I've been talking to. He's one of my podcast listeners. He's just been shit posting, but I know who he is. I know where he's at. And the thing about this application, you can change the radius of where you pull in messages from. So right now I'm at all, but if I go to 10 miles and I set back to my location, it reduces the messages to just people who posted within 10 miles around me. If I want to see everything so far, I just go to all on radius. I see everything. And then hashtags all get turned into overlays. So for example, I post a lot about Bulletin. So if I select the Bulletin overlay, I get to see everywhere someone's posted about Bulletin. But you know what? What if someone's interested in hookers? I don't know. I know that's wrong. But what if you're interested in hookers? Well, you pick the hooker overlay, and this will tell you where all the hookers are. It looks like they're mostly in Europe right now.
Mostly in Thailand.
Mostly in Thailand.
So Dan, I've got a quick question here. Could you help clarify how one RAD terminal can connect to another RAD terminal without internet, and then both of those RAD terminals also connect with the internet, like the internet here on your screen as we know it?
Well, okay. So our network is basically a distributed set of nodes. Each node will run a version of this application on Apache web server along with the software to connect to JS8 and transmit. So I'm on my node and I say, I want to post a for sale message. I don't have internet. So I do a message in our proprietary encoding language. I send it to JS8. It's going to post here on my application, but then I send it to my friend, Whiskey 7 X-Ray Romeo Oscar. Just made that up. Well, Whiskey 7 is connected to the internet. I give him a send message. I say send internet, or really just power tag or command tag www Whiskey 7. Here's the message. He takes that message and his system posts it to the internet. So here's the thing. As long as one node is connected to the internet, one node can shuffle messages up to the application. Does that make sense?
Yep.
And everyone else. And again, the more people we have using it, especially while the internet is still relatively stable, the more people we have using it, the more bandwidth we have for pushing these messages. Truly, I don't see people posting messages much bigger than a couple hundred characters, kind of like Twitter. And a couple hundred characters is going to take about 10 minutes, okay, to transmit. We're still working out the features, but 10 minutes. And you say, well, why 10 minutes? Well, a couple reasons. But one of the reasons is we don't want to harm your radio. So we're trying to pick a rate at which we can broadcast so we don't fry your radio at all. We control that. Like I said, the CB spectrums we're working in are fairly long wavelength, lower frequency. And so basically, you have to be careful about the data you transmit. You got to be really smart about encoding. We're going to be doing a lot with encoding. But even as we go up in frequencies, we're still going to be smart about bandwidth. You have to be. Beyond that, I'm really excited. I mean, I can tell you, working with Justin has been a revelation. The last year, and I've been here almost a year working here, has been great. We've done a lot with radio. RAD Engineering, which is a startup, which is what we're starting, has a lot of potential. This is just going to be one of our products. We have a lot of potential products in the pipeline. So if you're out there and you're interested in technology and freedom, contact us. You can contact me, planetarystatusreport@gmail.com, or Daniel Sullivan at Planetary Status Report.
I'm going to stop you right there. We acknowledge every single email. If you do not get an acknowledgement, it's because we did not get the email.
Yeah, and let me just get that out of the way very fast. For whatever reason, a lot of emails that get sent to me never get to me. You can fill in the blanks yourself.
Anything else, Dan, before we end it?
No, this project, we're excited. We're thinking about going to a trade show in a couple months, so we'll talk.
April 22nd, Sandy, Utah. Details coming.
Details coming. And other than that, we're about a week away from our first version of the software being done.